We're going to work on lab number 24 today. It's called tubular gas. And the first thing it asks you to do is calculate the theoretical volume after writing a balanced equation. And so if you're here in class, you will show me your volume before you start. For everybody else, and for this video, this is my piece of magnesium, and it has a mass of 0.046. You'll see in your procedure it says to get a piece of magnesium that is less than 0.05. What I'm going to do with the magnesium is I'm going to create a copper cage for it that kind of holds it in place so that when the reaction happens, my piece of magnesium will stay put, hopefully, or stay as put as we can get it. For those of you doing the theoretical volume, here's my copper cage, and this is what it's going to look like. For those of you doing the theoretical volume, the temperature of the classroom today is 21 degrees, and the pressure that is read on the barometer in the classroom is 750. Remember, we need to add 24.4 to our 750. Okay. Now, so we've wrapped our piece of magnesium. The next thing we're going to do is we're going to take a long tube. This is called a gas tube. It's closed at one end and it's open at the other end, and it's got calibrations on it that it's actually going to be held in this direction here. So you can see that at the bottom it's a 50 milliliter, and then at the top it goes up to 0. And we're going to be collecting gas in this. This is, instead of our trough and bottle, we're going to use this. So the very first thing that I need to do in my tube is I need to add hydrochloric acid. Okay, this is hydrochloric acid. It's more concentrated. 6M is more concentrated than the 1M that we've used in the last lab. It is more concentrated. We're using 10 milliliters. Notice your procedure says a red graduated cylinder. Here in the classroom, I like to use red for acids and yellow for bases, and water can be in either one. So what I did is I put the acid into the tube here, and then I need to fill the rest of the tube with distilled water. And so I am doing that just with a distilled water bottle. And you'll notice that I need to get it all the way to the top. And then what I'm going to do is I'm going to put in the top, I'm going to put my stopper with my magnesium and my copper cage. There isn't going to be a reaction yet because the water is still at the top, and the hydrochloric acid will sink to the bottom because it has a higher density. Notice my trough today is actually a graduated cylinder. Here it is right here. It's filled halfway, and you'll see how that is going to serve the purpose that I need it to serve. Looking at this, there's my copper cage with the magnesium trapped inside and the stopper. I'm now going to invert the tube upside down and stick it into the graduated cylinder. And we're going to, I'm going to try to get a close-up of this because we should start to see the hydrochloric acid coming down, and you can maybe see a little bit of action in there. The hydrochloric acid, if I look more towards the top, you'll see it kind of looks syrupy as it's dripping down. Remember what I said, it has a higher density than water, so it does start to sink, and when the hydrochloric acid hits the magnesium, which is at the bottom, we'll be able to tell what's happening. And so I'm gonna move my video stand so that we can watch, and we should be able to see gas bubbles. You can probably see them starting to form. There's a few gas bubbles, and those will get more rapid. You can see they're forming around the magnesium. The copper right now won't react with the hydrochloric acid. It does eventually react, but the magnesium reacts much faster. And so it's creating a gas now. And you can see it bubbling. And you can see it bubbling up my tube. And it will start to create a space up there already. We're starting to see a volume of gas at the top. And this is one of my favorite labs because it looks really cool in the gas tube. Trying to get rid of my camera stand here without knocking my tube over. Okay, so here you can see there's quite a lot of action now as the hydrochloric acid has hit, and you can see those bubbles coming all the way up the tube. And it's creating more and more space. My reaction will be over when the magnesium is gone, but the bubbles will also stop, so it'll be relatively easy for us to tell when the reaction is over.